All right, welcome to HTM Hackers Hangout. Thanks everybody for joining today. I appreciate you taking the time out of your busy schedules. I know we've all got stuff to do, so I'm going to get right to it. Today, let me turn my camera on the whiteboard here. I have an agenda I'm going to talk about. So just so you know, if you want to zoom forward in the video or something, I'm going to talk about Python 3 first. So of course, it's a big topic because the end of life Python 2 is right around the corner. I'm going to talk a bit about NuPicTorch, which is a PyTorch package that, as soon as I do the review, is going to be open source. So next week, probably for sure. And then I'll talk about what I've been doing on Twitch, just and tell you what my plan is there, because it's I've felt traction there, and I'm going to keep using it, and I've got a plan to engage the community. Hi, Mark Brown. I see you. Looks like we worked out. So let's see. I'm going to go. Well, let's just talk this out. And I'm glad you're here, David, because the first thing I wanted to talk about was Python 3. So we've been looking into it, and we've already created a Python 3 package called NuPicTorch. And Python 3 has this idea of namespaces in the packages. So you can pip install, for example, nupic.torch. And in Python 3, sort of that environment, this idea of a namespace, this dot is special, and it means that we're expecting to produce nupic dot something else and something else and something else. So I'm trying to figure out naming for projects as we move out of the Python 2 to Python 3 realm. And what I really would like to see is, I mean, it's logical to think of whatever we end up with being NuPicPy. And that is currently the name that you guys have given to the repository for the fork. And we still have not got to the point where we're making a decision yet on whether we're going to take nupic.cpp or nupic core and do bindings for which one yet. I mean, we're going to have to do that really soon, but I'm just putting the decision off at the moment. But I do want to toss this idea out about naming things. If we come in a situation where we have two Python 3 projects, this may or may not happen. I just want to have the conversation. We might have. I think it would make more sense to have an HTM Py, which would be the community version, and this one, which would be the Numenta version, if this happened. Now, I would really like for this not to happen. I have a goal to try and steer the ship and see if we can take all the work that you guys have done, especially in NuPic CPP, and see if that core is enough for us to move ahead with the research that we want to do, and create the bindings. Maybe we use NuPicPy as is. Maybe we create a very small package of Python 3 bindings directly against nupic.cpp just for research, whatever we end up doing. I don't know, but we're going to have to do it pretty quick over the summer. This is something that we have to do. So I wanted to float this idea of what are we going to name things in Python 3, and the potential of a name change if this happens. And I don't know how you feel about that, David. Particularly, I want to ask you, since you're one of the fork contributors that's online right now.
Well, we'll do whatever you guys want to do. Our goal is to support what the community is looking for.
Okay, great. Like I said, I would rather not have two packages. I want to steer it towards, hopefully we can write whatever we need for research against a clean version of NuPic C++, but we're going to have to spend some time evaluating that and making sure that we can adjust our research. Hopefully there won't be much adjustment to do, but we haven't even attempted to start the exercise yet. So it's totally coming. So I just want to just to float that idea about namespaces. Next week, particularly like Wednesday, I'm having another meeting with the team, and we're going to talk about what the forcing function is going to be internally for Numenta research. It's hard to force scientists to move from one programming environment to another. Okay, so Lewis and I are working on this to put a forcing function in place, basically saying no more new code unless it's Python 3, period. If you're running anything in HTM in Python from this point out, it's going to be Python 3. And what that means to us, what we're going to have to do, the work we're going to have to do. So we're going to talk through all of the details of that work, I think, next week, and we're going to put something in place. So we're going to set a date, and we're going to say, this is the date we're going to go Python 3. This is basically what we think we're going to have to do to make that happen. And everybody's going to have this expectation that we're going to have some overhead in dealing with that. So the ball is rolling. So I just want to let you guys know that. That's where we're at right now. And as this goes along, you're going to see me hopefully working on this on Twitch. So you'll kind of get a feeling for what the struggles that I'm having and the needs that we have to support research. So I'm hoping the transparency involved here is going to help everybody in the long run have the tools that we want, right? So that's the plan with NUPIC and Python 3. It's a loosey-goosey plan, but it's a plan, and we're taking steps forward. So, any comment about that? And anybody who's watching on YouTube, for sure, if you're invested at all in the HTM community or HTM forum, let me know. I'm open to comments on this. I want to do what makes sense for everybody, and like I said, I'd love to have just one Python 3 HTM package, but in the end, people are going to write their own. So, but we want to use one. HTM research is going to need a stable version, and I'd love to try and use the community fork, but I'm not making any promises. We're just going to have to get to that point when we get there. Okay, so the next topic then would be the PyTorch package. This is basically the same code that we released with that paper that we've been talking about on the forum, that Marty and Josh Simleek, Marty the Teapot and Simleek have been working with. So Marty's already got an implementation of this. Simleek already had an implementation of it before we even had the paper out, just from talking to me on the sidelines of the forum. And then I think a lot of things fell into place when the paper came out. And so we're going to have basically that code just packaged in a nice way. Lewis has been working on this, packaged in a nice way so it can be easily incorporated in PyTorch projects. So there will be like a modular K-winners module, and what was the other one? There was the other module. Anyway, the modules that were required to get this to work are packaged up and easy to add to, or to create PyTorch modules with it. So that's coming, and I'm the bottleneck on that right now. Lewis already showed it to me. I just have to, make sure it looks good. It's got the right license, and there's a couple of boxes that need to be checked before we can make code open source. So that's on me. I'll get it out next week. Any comments on that, on the machine learning side? And I know that's sort of been some new stuff that we put out there. The noise resistance thing with the MNIST. So we've gotten some interest on that. I think people are starting to see, hey, this could be something we could explore more, right, in the deep learning space, which is what we wanted. So we're going to keep going in that direction and see what else could we take advantage of, in the machine learning space. How else could we apply these ideas? Okay, so the last thing I'll talk about is the Twitch stuff. And I don't know, I know most of you have probably seen what I've been doing on there. This has been like a drastic change for me, although it feels right. I think it fits well. It's just thrown a monkey wrench into my whole process. And it's adjusted some of my priorities. So I'm going to lay this out for you guys, because you guys are sort of my sensors in the HTM community. I want to know how you guys feel about this direction that I'm taking, because what I'm doing is I'm laying off the videos. I'm backing off the videos. And because I feel this traction I'm getting in Twitch, I'm feeling a much higher community engagement there. And I think that the key to this is the community coding projects. It feels like people want to work on this stuff, and they want somebody to kind of guide them along. And I'm happy to do that. Actually, I think I'm in a good place to do that. I actually understand most of the theory at this point, whereas 3-4 years ago, when I was still doing this, I didn't understand the theory, honestly, well enough to guide anyone into making anything. So now there's three things I want to do on Twitch. I want to expose research in the form of research meetings, which I've done only one of, but it's been a slow week. But I'm going to continue doing this. Jeff is psyched about this. He wants to continue streaming research meetings. So I will continue to do that. And then I also have established this weekly show, and it's sort of a chat show. It's about AI and neuroscience. So the thing about Twitch is there's a science and technology game, right? Because Twitch is, you have to choose a game that you're going to be streaming on. Hi, Sam. Nice for you to join in. So you choose a game, and it's like at some point they thought, well, there's a bunch of live coders that are doing things, and so let's make a game for them. So they make science and technology. And so you see these robotics competitions and all this stuff. But the field is so empty when it comes to scientific education, programming education. The tool suite that Twitch gives you is perfect for collaborative work, for interactive work, for remote execution and planning. It's great for programmers. It's like the perfect set of tools for collaborative programming over a distance. It is right there with Twitch if you can take advantage of them. So I see that and I'm like, this is perfect for an open source community manager like me to do exactly what I should be doing, and setting up these community coding sessions and talking with people in this Twitch community about neuroscience, about AI, because nobody's talking about AI on Twitch. Nobody. And it's this big science and technology section, and I feel like I'm the only person having a conversation about machine learning, AI, how it could apply to games or whatever. So it feels like I'm in a really good space to create a bunch of content. And so that's what I'm doing. I'm trying to create a bunch of content. I'm trying to engage a community that wants to learn about this stuff, because we seem to be the only loudspeaker in this giant space right now. So I'm just going to create a bunch of content. That's the plan there. And engage people who want to learn about what we're talking about when we say strong AI versus weak AI, cortical columns versus mini columns, the neuroscience technology that we want to try and make more common in the machine learning community, like talking about the thalamus, talking about the cortical loop, talking about the different types of synapses and dendrites that there are, if you want to really model things about spike timing, there's all these things in neuroscience that I would love to continue to expose there. And that's the plan. And the other thing, here's the exciting thing, is the community coding. So I've got at least 3 projects. I've been going on about the 2D object project, and hopefully a few people are really engaged in that. So I'm going to continue to work on that and define this test, sort of I'm going to do this via something called behavior-driven development. And the reason I like this is because I can describe test scenarios in English, completely English, and then other people can write the code to pass the tests in what language they want. So right now it'd be JavaScript, Java, or Python. That's what we're working on. So I'm going to work through live on Twitch sort of this object recognition task that I've been talking about on the forum, and create some solution, probably in JavaScript. I don't know, maybe because doing it in Python 3 might be hard at the moment, but I know I could probably do it in JavaScript. So I might use Paul Lamb's implementation of HTM.js and work through a solution to start constructing this. And what that'll do is it'll build out a huge test suite, all of these features that will be in English. And then anyone else who wants to throw their hat in the ring and use an HTM like HTM Java to solve the same problems, we'll have an example of how it could be done, and also a test suite to run against it. And so then we could turn this into a challenge for people. If you want to learn HTM, if you want to learn an HTM system, here's a set of tasks to accomplish, and here's also reference code in a language of showing how they can be accomplished. So this is something that I'm going to work through on Twitch, mostly live, over the next, I don't know, year. I don't know how long it would take, a few months. I tend to not get much done on Twitch. It depends on the day, but sometimes it's very hard to get things done on Twitch because there's a lot of interaction. But at the same time, that's why I'm doing it, because I want to engage an audience too. Okay, so that's one project that I'm excited about. Another project is building HTM systems, and that is currently it's that building HTM systems if you want to go look at it. But I wanted to create a full-on guide to how to build HTM systems with visualizations all along the way that shows. I've got several encoders working now, but I wanted to go on to the spatial pooler, build a spatial pooler, and show how it works. So it's sort of like the HTM school animations, but live. I want to have this be a server that stands up, runs in HTM, has spatial pooling, has a temporal memory that's constantly flowing some sample data through it. Some live temporal, could be semi-random, whatever, but something live through it. And all of the pages that are displayed that are describing will be showing a live stream and the algorithms running on it and some visualization of that happening. So I've had a vision for this for a long time and I've never had time to work on it. And now I'm thinking this would be something I could do on Twitch and build out an HTM system essentially. Okay, so that's another thing. And the third thing is community projects. And what I'm really meaning is like other HTMs, let's say. Like I said, I might solve this with HTM.js, and that would be an introduction to the HTM.js framework. I could solve this with nupic.py or py3, which at some point, hopefully, whatever is the Python 3 version, or we could do it in Java. So these explorations could also be something that I could sort of do as a newbie coming into this and try and figure out how it works and do this live. And I think it would help the community because they can see someone engaging with the work that they've done and show other people how they might also build things with their frameworks. So these are sort of the ways that I plan on engaging with the technical community of builders in the HTM Hackers community over the next year or so, which has totally changed from my original direction this year, which was to make videos and finish this building HTM systems, but turn it into like a WordPress document. I don't know what I was going to do, but not on Twitch. So this is the direction that I'm going, and I'm open to feedback about this direction. Do you think this is the right way to be going? Because I'd like to know. Thumbs up from Sam. Okay. See, I can't. Go ahead.
I think it sounds really good. I've been the building HTM systems kind of was started and then dormant for a while. That's the one that's got it's got all the encoders and then it's got kind of placeholders for everything else.
Yeah.
Yeah. Yeah. The placeholders look like things that would be cool to have finished. And so you're talking about something that it's like a course that's kind of got a consistent reference sort of implementation as you go through.
Yeah, exactly. So what I'd like to have, the code references in the page actually are the code that's running the simulation that you're seeing. So far, I've got that in the encoder section, but that's a goal of mine, is to try and keep it very pragmatic all the way through.
So it could kind of almost replace some of the, well, not replace, but you wouldn't need to use go through the videos of HTM School to learn encoders. Originally, you could kind of go through that process instead.
I guess would expect this to cover all the topics in HTM School up through temporal memory, and then it would also replace BAMI. I hate to say replace BAMI, but it would continue where BAMI left off because BAMI didn't really finish.
Do you have any thoughts on how you're going to express those object recognition scenarios with BDD? Because I've used Cucumber before in more of a business logic testing scenario where you say, customer buys a product and it goes in the cart and that sort of thing. But this is really a bit unique. You're talking about something navigating a grid. Are you going to be describing that in English, or are you going to be trying to draw ASCII art pictures? Or
no? So I imagine it's going to be English and in the Gherkin language for Cucumber, and the types of scenarios that I'm thinking. I thought this through a little bit in my last Twitch stream this morning, which was supposed to be a research meeting, but just turned into me talking about test descriptions for this project. If you want to check it out, it's on YouTube too. So I'm starting to think this out, but I think it's possible that you should be able to. So, I mean, every one of these language implementations is going to have some code that loads the object schema, and load an object and then serve it to an agent, right? And so there has to be an API there. So the BDD will initially start with an object library of some kind or an interface for the object to be loaded and inspected. And then we'll move on to an agent representation or something that, when given an object, has the ability to move through. I mean, we have to start really simple. And then once you've described these key components of the system, I would move on to, okay, the scenario is training, a training scenario where an agent is, where we write the rules for what training is essentially. Maybe we end up with some type of training schema, so we can say this object gets to get this many touches in this order, or use this movement path. I don't know. These are things we're gonna have to work out as we go along. But I don't think there's anything in the BDD idea or in Gherkin that's going to prevent us from doing this. From my experience with BDD, you can use it to test anything. You can use it to write any kind of software.
Yeah, I jump in here.
Go for it.
Okay, what I'm thinking of is your deal about writing code on Twitch. May I suggest that perhaps what you could do is start with the BAMI pseudocode and show that being fleshed into real working code. There's an awful lot of people that are struggling with how to go from the concept to the code, and we're getting some newbies here that aren't real good with that. This might be something that kind of walks them through that and gets them familiar with the process. And in the meantime, you also would end up with some running code out of it.
So that's a good idea. So that would be, that would probably be part of this, because the next big section is the spatial pooler. So that's essentially what I would be doing, looking at the BAMI code and trying to figure out how to implement it. So you're saying I could probably prioritize this a little sooner, because we've got a lot of new people coming in wanting to understand the next part of this system. So that's good feedback.
Right. And the feedback on that, what you just said is then once you've got that in the can, you can point people at it when they come at your Twitch and say, hey, I'm excited. I like your AI stuff. What do I do?
Yeah, exactly.
And this you could point to. Okay. The other thing is, anybody here following TensorFlow 2 and Keras? Apparently, they're going to make TensorFlow all warm and cuddly so that you can actually talk to it through Keras and actually get something done. I've been following this very closely. Keras
is a streaming protocol, right?
Yes.
Okay, well, that's good. That's good.
If you haven't looked at it, do a Google on TensorFlow 2 and see what you think. That's all I got.
Okay, thank you, Mark. Appreciate you piping in. TensorFlow 2 and Keras. Keras, K-E-R-A-S, I believe. Okay. Anybody else have any input at all? Let's just open it up. If there's a discussion someone wants to have, now's a good time to have it that we can't have on the forum anyway.
Yeah, I have a concern. Do you hear me?
Yes, Falco.
Okay.
Thanks. Go ahead.
I'm super psyched about everything you do. It's really, really interesting. But there are about 10 to 15 followers, and it's great. Everybody's very interested. What will happen if we have 50 or 60 or 100 followers who all pipe in every split second? I mean,
you mean on Twitch?
On Twitch, yes. How?
Don't worry about it. Let me handle that.
Yeah. Don't worry about it. What if you have a bunch of trolls who just are there to...
I can handle it. I can handle it. It will not decrease the value of the channel, I promise. There are tools in place that I can use to handle high volumes of traffic. If that happens, I would be ecstatic that I have that problem to solve.
Okay.
But I wouldn't worry about it right now, because from what I've seen of Twitch, there are tools in place. I just don't need to use them yet.
Okay. All right. Great.
I don't mean to discount your concern. It's a valid concern.
No.
I just want to say I've totally thought it through.
Okay, great. No, that's okay.
Okay. Anybody else? Oh, Gary's in chat too. Let me. He says, in regards to Python 3, my first thought was that we should use for fast hexagonal arrays and graphics. So, okay. Anyway, go ahead, Sam.
Sure. It's just a little just self-indulgent for a second, but so first I want to tell you that I got a data science job, and I think it's pretty much because of what I had done with HTM, and now that I'm here, I'm bringing them HTM, which they didn't know about. So if you guys wouldn't mind me just building my entire career right on top of your back, then
you're an HTM ambassador. That's absolutely fine.
Yeah. So I've created my own, wrapper class to try to do the anomaly detection stuff. But anyways, I wanted to so thank you, and I'm really excited and happy, and yeah, people are interested, and makes me and that's really cool. So for you to know about that, it's a major company too. So it's going to help stuff, get into the bloodstream more. I wanted to, well, actually, okay, I guess I won't ask you this year because maybe it is more of a discussion thing. I would maybe bug you to check. I made a discussion post like 2 days ago. I'm trying to, for my implementation here, for very practical industry purposes, not just my own stuff. I'm trying to make sure I have full control of the anomaly likelihood, because that's sort of the ultimate filter that actually decides things. And so I'm getting into that more. I wanted to, I know there's a sort of a slight batch mode with it, and then there's more of an online mode where what I was doing was just creating the anomaly likelihood object and then feeding it data. But I noticed that there was a short-term averaging window of 10, I think. Yeah. And I guess what I wanted to be able to try to do was to change that, maybe make it less or even 1. Because what I want to do is, what I want to basically make sure that I have is that I understand, like, let's say you have sequences that are much shorter all of a sudden, maybe shorter and simpler, as opposed to more noisy, real world, longer term. What I'd want to be able to do is be able to make sure I know how to control everything, such that if I made the sequences all of a sudden only really short, like 10 or something like that, that I'd be able to change the settings so that I still got the anomalies that I feel like I should get.
Well, let me pause you right there, because something didn't ring right.
Okay.
You see the sequences are shorter. Now,
right. Yeah.
Does that mean that you're resetting sequences? Are you calling reset on the temporal memory?
No, I'm not resetting.
So hold on there. The sequences are not shorter then. The sequences all go on forever.
Right.
So
right.
I mean, the patterns that you're looking for are shorter, but because you're not resetting the temporal memory at any point, you're never telling it that this is the end of an object, this is the end of an object.
Yes.
You're relying on an anomaly detection that's happening over all of these being created over time at once.
Right. Yes. No, I know that the actual, the TM core learning doesn't change because it's just the continuous learning. I just so for instance, in anomaly likelihood, there's there's the total window size, and then there's that averaging window. So what it looks like is, by default, it'll look back at the last 8,600 points and compare a rolling average of the last 10 points, and then do that, the tail probability thing, and say, is this a high enough likelihood? So I basically want to say, if I were to generate data that I knew were shorter sequences in that sense, I'm generating, some data, and then I inject a change into that data, like you guys did in that paper where you had the one pattern and then you switched the pattern, you reversed it, and you saw how long it took to recover, right? And then you could say, okay, here's how long it takes for it to start predicting well again. So that was the measure of how long does it take to predict well again? But in terms of an anomaly sense, right, if I have a bunch of patterns that are 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then I go 5, 4, 3, 2, 1, 5, 4, 3, 2, 1, 5, 4, 3, 2, 1. I feel like if the averaging window and sort of those hyperparameters of the anomaly likelihood are too big, it will sort of have a bigger gaze, but the action is small in a small space. So I just want to be able to flex to that situation, just so I have a full control. Because when anything, it's if anomaly doesn't get detected, then I probably have to answer exactly why. So I know that I can't answer exactly why, but I want to at least be able to say, okay, maybe if I were to, that could be being affected.
So I'm not sure this is something you want to do in the anomaly likelihood code.
Okay.
Because I hear that maybe you're just saying you want to forget sequences faster, or you don't want to remember longer sequences. You would rather remember shorter sequences. Is that true?
All right. Well, it's so I don't want the temporal memory to work any differently. I want it to be where, let's say, so if the default look back is 8,600 data points, it's 8,640, and then the default average time is 10, right? But let's say the data that I have is only 500 data points, right? So maybe that sort of larger window that slides over time, it doesn't have enough space to slide anywhere. So you're always using everything, right? But maybe if things are sort of shorter in terms of their time you know what I mean, like on a smaller time scale, where you might want to have that window smaller so that the overall distribution you're comparing to could adapt more so in that case. I just want to make sure that I have full control of that so that I don't feel like there's anything going on that's beyond my...
Isn't there a way to just set the window size when you create an anomaly likelihood object?
Yes, yes. So you can set the historical window size. I don't have a problem doing that.
Okay.
It's the averaging window, because it's not actually a class attribute. It's just a defaulted, like a hard-coded input into it. Just like so you pass into the function, which is not like so I can't just say anomaly likelihood dot attribute equals this. I would have to pass it into that function. And so I'm trying to use that lower level function, and I'm just having trouble doing it. We don't have to go into this on here. So I'm sorry, I don't want to take up all this time.
No, that's okay.
If you wouldn't mind reading my post on that.
I'm just looking at it here. I honestly bookmarked it and didn't. It looked complicated, and
yeah, you're welcome.
So what you're talking about, though, sounds like a code change. It doesn't sound like. So what you could do without making a code change is extend anomaly likelihood in your own code and add this property that you want, make it a part of its configuration, and then rewrite the function that does that calculation in your own code to add it.
Oh, okay. So just like augment the source code that I'm using.
Well, you don't even have to augment it. You can just create a new class that extends the anomaly likelihood and then override the functions where it does the calculation.
So inherit the anomaly likelihood class and then just overwrite that part of it.
Yes. So call super in your init, pass it the parameters it wants, but store the one that you want in addition to it. Override the function where it calculates it and add it to the calculation.
Okay.
Okay. Yes, go ahead.
Okay. We have the same problem at work. What we do is we process streams of data that we try to average it to find a reduction in noise. And when we see a large discrepancy or when the buffer is, what we do is reset the buffer length to a very short distance and then extend it progressively as the data streams in until the buffer's some predetermined length. So what happens is when there's a large anomaly or where there's an undesirable change, it quits leaving, or it throws out the junk and starts over. What you're talking about here, where you have an underflowed buffer, that's suggesting you would start with a smaller buffer so that your averaging works properly and then extend it as you go along.
You mean the averaging window, that short window that I think defaults to 10? Or you mean the historical window size is adapting?
I mean, you pick whichever one you're trying to optimize, but the idea being is that rather than have a fixed window, your rolling buffer, basically you average then divide by the number of samples. So if you have a larger buffer, when you have more data to work with, then it makes sense. You're saying you have a buffer underflow. I got that.
Right.
I'm suggesting that you might want to consider the fact that if it doesn't kill your code terribly, to play with the buffer size.
Right. Assuming you know the size of the data coming in, because then you can say.
Yes.
Right.
Okay. And if you're early on and it's early days and you don't know what it is, then either turn off your averaging until you get a buffer full, or start with a smaller buffer and extend it as you get more to work with.
Okay. So to have a dynamic update of that buffer, right? Like, so that's what you guys do in your
That's what we do.
Workplace.
We're averaging weights, so I mean it's not the same thing at all. But the concept is we mess with the buffer size to fit the data.
Okay. In a dynamic way, because you said you had to deal with streaming.
Yep. That's exactly right.
That makes sense. That makes sense to me. And since you'll be overriding the class or extending the class now, you can write it how you want.
Okay. Can I? Okay. Maybe. Mark, I'll make a post to you, so I don't want to drag everybody through it. I want to make sure I understand the details of how you update the buffer, but I don't want to drag. I've already been dragging everybody around, so maybe I can make a post if you wouldn't mind, or something. Whatever is not obnoxious. This is very relevant.
Okay, one other thing, as long as I'm up again, notice that when people are asking questions on the forum and Twitch, I keep dragging them back to the neuroscience as the inspiration. You guys that are writing code, is this counterproductive or is this helpful?
It's helpful for me.
Okay.
As much as we could take it in, yeah. Yeah, it's definitely good though.
One of my goals, I think, is to make people aware of what we're modeling. I mean, you have to understand what we're modeling to really understand what you're doing here. So yeah, definitely point it back to the neuroscience.
Okay, well, that's been my go-to because that's what I've been studying for the last, I don't know, 30 years. And I can see the similes to what the actual, like, for example, we're getting questions today about the pooling, and they're still, in straight HTM, we're modeling such a tiny section of the cortex that having an input area that covers the whole field, okay, that makes sense because it's actually not that much more of a reach than a single cell could reach in the cortex. As your models get bigger, the processor gets faster, that you need a neighborhood more than you need that. It's a different approach, but as our processor keeps getting faster and we can do more with it, that may become more of an issue. So that's something I point at from time to time, but that's an actual question up today that I was looking at and trying to think about how to answer that.
Well, that's really relevant, and I think you should point that out because it's absolutely true. And we're not going to take full advantage of this system until we get the hardware that can handle all the parallelism that we need to run thousands of these things at once.
Well, my new box I'm putting in here in my home office is a Dell 3600 off lease, $300. I mean, that's cheap enough I could afford to put a whole row of them in.
Yeah. All right. Oh, so Sam, congrats on the new job. Very happy for you.
Thank you. Thank you, guys.
Anything else from anybody else?
Matt, you should send them a box of Numenta cups, I think, so you can pass them on.
Yeah, the Numenta cups. Yeah.
Yeah. Eventually, we'll have a physical meetup, and I'll bring a box of Numenta cups wherever.
Yeah. Oh yeah, and I'm in the Bay Area now. That's where the company is. Not that you necessarily
really
care, but
lazy about the physical meetups the past couple of years, so I apologize for that. We will have one at some point, I know, but I'm so focused on the online collaboration stuff right now.
Well,
honestly,
let me know if there's one on in early June because I'm actually in the area. That's my one time in probably the decade that I'm in Bay Area. So,
well, either way, shoot me an email and maybe you can drop by and say hi.
Yeah, cool. I'm there for a conference, but I'm sure that there's time around it. Actually, speaking of that, it's a conference for a data warehouse product called Snowflake. And I've actually been experimenting with in-database processing and thinking of applying it to HTM. I'm kind of imagining like a in-database version of HTM Studio where you can do a anomaly detection on say a scalar stream.
Yeah.
Because it supports JavaScript in stored procedures and table value functions, so you can actually do quite a lot in it, and there's a lot of compute power behind it, elastic compute power. So I'm thinking it might be useful, and I started looking at it, and it was all fairly easy until I got to the part where you have to make the prediction back into the value. That little sort of I think I asked a question about it a few weeks ago on the forum. So I've used HTM JS, and it sort of does everything I need except for it won't tell me an actual value to predict. It will only tell me that something's different.
Oh,
makes sense.
Is that maybe that's the problem with the implementation? Maybe it doesn't have prediction implemented. I'm not sure.
Well, it doesn't. It's got very basic. It's not the same as the what's it called? The predictor that's in NuPic actually has like a little
a classifier.
Yeah, the classifier. That's right. It doesn't have that, and so I'd have to implement that as well.
Yeah, that should, hopefully that's simple. You should be able to use like a standard deep learning classifier to get that.
They're just I'm trying to keep it pretty lightweight because it's running in a database. But anyway, that was my plan to kind of just have a SQL statement you could run that could do some basic anomaly detection in database.
So along those lines, there's sort of a thing. I worked on this a long time ago. I've thought of the same thing. There's a time series database called Influx DB, and I created a project that worked on that and basically connected HTM to the Influx API. So we basically just attached to a screen. So you could just attach, HTM to any one of these scalar temporal streams. It just has to be a temporal scalar stream, period. And you just say start here, end here, and run anomaly detection on it. And then it will store data back into it along with the data. So you can store your prediction or your anomaly score along with it. So you're thinking along the right lines, I think. I think that's a powerful tool.
But you would have had to, was that running NuPic external to the database?
Running NuPic on a server. I have an HTTP server I run NuPic on called NuPic HTTP server.
Okay, so this would be virtually the same exercise, except at the end of the day, you wouldn't have anything external to the database. It would just be the actual SQL engine would take care of it.
That's cool. I think that's cool. That's a good application because, database has got tons of data and they all got timestamps on them.
Yeah. I'll post, if I get further with it, I'll post some updates on the forums.
Okay, cool. Thanks, James. James or Jimmy?
I go by both, depending on the context. Jimmy's more consistent with my my discourse handle, so we'll go with that.
Okay, I'll stick with Jimmy. All right, anybody else? Keep the lines open for a few seconds. I think I covered everything.
Hello?
Yes, Josh.
Oh, there we go. This app is confusing, sorry. All right. So I was noticing something when I was playing with my own version of the spatial pooler on the PyTorch repository. I got boosting and the k-winners implemented, so I feel like that's pretty close, but not the inhibition. But I was noticing with some other things, sorry, this is confused. The autoencoder for typical convolutional neural networks and deep learning, there's a variational version of that, and it seems like it'd do kind of the same thing if you had the inhibition be learned. So didn't communicate that well, but.
So you're talking about a variational autoencoder.
Right.
And the inhibition you learn, are you talking about local or global inhibition when you're talking about this?
Yeah, right now I'm just doing global inhibition, but.
Would it work any differently if it were doing local inhibition?
I don't think it would work too differently, but it would be. I'm just testing my current autoencoder on a very small input image. So I believe with respect to that small input image, it would be the same whether you did local or global.
Okay, and when you say inhibition is learned, are you talking about the ways the spatial pooler learns?
Well, it would be instead of the global inhibition where...
Inhibition is learned, are you talking about the ways the spatial pooler learns? But I'm going to mute you.
Wait, what just happened there?
Somebody joined and they had their mic on. It's okay, go on.
Okay. All right, so instead of having the global inhibition value sent to the other neurons or locally sent by a value, I would grow dendrites to the other neurons to specifically turn them off if this one neuron was receiving input.
So you're saying you could change the idea of a variational autoencoder by adding learned inhibition in the way the spatial pooler learns inhibition.
Yeah.
Okay.
If the variational autoencoder would be similar to the learned inhibition.
Okay, that's interesting.
Yeah. Not sure how valid that is or not, but I'll try and test that.
Yeah, let us know what you find out on the forum. And hopefully once I talked about NuPic Torch earlier, but hopefully I'll get that out next week. It's nothing new. It's just an arrangement of the algorithm so that they're PyTorch modules.
Yeah.
cleaner, you know.
All right. Once I finish up my stuff, I think I'll try and add to that.
Okay, cool. Thanks, Josh. Thanks for all the work you've been doing. You seem to be right on the bleeding edge of this, you know, machine learning application of HTM, which is nice. I love seeing people working on the edge.
Well, thanks.
Okay, hi Kai6. No worries. Just wanted to say hi. Saw you over there. If anybody else have anything to say? We're just sort of wrapping it up. Gary is on chat. He's talking about hexagons on chat, but it's not the chat that we see. It's the other YouTube chat. It's the one on the YouTube page. He says accounting for hexagonal connections has always been such a chore that I had to mention what I most need right now for a Python related standard. So he's talking good about Python's 3. His first thought was that we should use it for fast hexagonal arrays and graphics. So he might end up creating some package for Pygame that does that sort of thing. Hexagons, it's all about hexagons. Okay, I'm gonna open up one again.
Super quick, Matt, if I could just prod you to, I made one other post today, and that there's this guy was already responding to it, but it was basically in terms of setting the encoding parameters, because I was worried that in some of the data I'm dealing with, it's like long tail distributions, where most of the data is here, and then, but if you were to take the max, it would stretch out the space. Yeah. But I also don't, so I'm balancing between, you know, not, it's like I want where most of the action is, I want to be able to distinguish between the close stuff, right, but not just, you know, treat everything that's crazy like one common thing. Right. So what I've been doing now is, because I don't want my, because some of the data, like I don't, it's just these crazy high numbers. And so I'll wind up taking like sort of the opposite of the padding thing, where it's like, instead of taking min and max, I'll take like maybe like the 95th percentile or the 98th percentile as the max, and then like the 5th percentile, basically to try to avoid getting stretched out by some crazy long tail. But this guy was making a point about how maybe the spatial pooler learns to distinguish even similar like more similar values, but, or maybe because of RDSE or something, that it would sort of like flex to that. Because anyways, I know this has a big effect on the system.
It should work, but he's right. I think the spatial pooler should adjust for the tail, and the RDSE and the scalar encoder are really similar. I mean, it's just a different method. So, like, if you have a long tail and you encode that tail in the RDSE, it will move through all of the buckets all the way to get to that tail off to the side. So it'll be semantically very different from everything else, and that's
right. It does stretch out the space, basically. Like
yeah, it totally stretches out the space as much as you need it. You know, that's the whole idea with it. It'll stretch it out as much as you need it stretched. Whereas a scalar encoder, you have to put the min and max, and you got control.
Okay. So then maybe I should just leave. Like, I guess I could. Of course, try just maybe instead of chopping off 98th percentile, 2nd percentile, just take the min and max and let it, you know, let it sort of deal. I don't know.
You know, you're gonna have
try
to
it.
I tell everybody when you in a question like this, I try it both ways and see what works best.
Yeah. There's no theory really to it, I guess. But okay, thanks.
No problem.
Big question. Have you considered logarithmic scaling on the buckets so that you spread your sampling out? Stick the really, really rare stuff out at the ends and collect it in a single bucket.
When you say logarithmic scaling on the buckets, do you mean as like a pre-processing of the data?
Yeah.
Into a log scale? Okay. Oh, cool. All right. I'll go ahead. I'll try that because that way, okay, that'll kind of make the distribution not so long tail. Basically, it'll kind of make it.
What the eye and ear both do is logarithmic scaling to deal with that exact problem.
All right, you man. Awesome.
Thank you. Also, you should check out the logarithmic encoder in the NUPIC log encoder.
Oh, so I wouldn't have to pre-process the data into log if I pass it in raw, and then it would go into a log encoder, into the log encoder.
Yep. Sorry, I got some noise here. Sorry. Siri just trying to do something too. So anyway.
Okay. So then I would just say if I call the get scalar params with get scalar anomaly params, it gives you RDSE, but I could just then go in, have a function that takes that, goes in, changes it to the log, because I'm trying to do this all like automatically and like dynamically for different measurements when I don't know what the measurements are going to be at all. Right. So then just to say, okay, instead of RDSE, try log encoder.
Yeah, I would try that. Right, okay. Try that first. I have never tried the log encoder, so I don't know I don't have the details. I'll put a link in our chat. Hopefully you can see that link.
Hey, you could try tossing into building HTM systems.
Yeah.
Sorry.
Okay, think about the year. It covers like 10 orders of magnitude or something like that from loudest to quietest. And it's log encoding first, stuff spreads out. It's just I don't know if that'll work for your problem, but it just sort of jumped up the suggestion.
Yeah, definitely worth trying. That's great. That's great. Thank you. Thank you. That's great. And I'll write one post to make sure I understand the logic of your updating thing, because that's really interesting, and I want to get that. If I could just bother you for that, possibly briefly, I will do that if you don't mind. All right. Thank you. All right. What an ally.
We had a really busy Hackers Hangout. We still got 10 more minutes, so I'm willing to keep this open. Well, you know, I think I made it half an hour. You know, it doesn't matter. I'm willing to keep this open if you guys want to keep chatting, or if you have any more questions. Otherwise, you can certainly check out my Twitch stream, because I'm online every week now.
Loving it.
Can I ask a question real quick about the I'm Cairo on the forums. I work a little bit with Rod Rinkus on Sparsy, and he has really structured encoding fields.
Yeah.
So I'm wondering, you guys were talking about the fact that the single neuron is such a small field with the layers that you're using, that it's really okay that a single neuron sees the whole receptive field. But when you start scaling that up, how are they supposed to be talking to one another?
Well, the neurons have to be segregated into different populations, and then each population, you know, Mark's laughing. Yeah. I'll let you. He's probably going to give you a better answer than me, right? But you've got to have a bunch of different, essentially, cortical columns, and they all are doing their own local computations, and they have their own local receptive fields. And then they all share information with each other amongst these lateral connections. Mark, go.
I'm a little off the reservation here. That post that I put, the long rambling thing about HTM into grids, that's the whole concept there is structuring the interaction locally into a larger coherent pattern. The Thousand Brain Theory is doing pretty much the same thing, but a different idea about what the output should look like. Lateral connections for the win.
Yeah, it's all about lateral connections. And I think Mark's he's got a lot of ideas about the hexagonal grids, and it doesn't really go counter to any of the HTM stuff. We're just stopping at the point of those lateral connections, and we're saying the cortical columns have to share representations via lateral connections to inform each other. And Mark's ideas have taken these ideas from Calvin's book about hexagonal structures at this bigger macro level, and repercussions of that.
Okay, yeah, because in Rinkus' Sparsy algorithm, he uses the lateral connections of the last frame to kind of do the temporal pooling and the spatial pooling all at the same time. So if a neuron is kind of looking down at the receptive field, and then it's also seeing its local neighbors from the last time step, that's like an encoded locally based temporal context to it. So that's what he thinks the lateral connections are used for. But his is based off of a familiarity. It's not really like union overlap or anything like that. It's a familiar. He calculates it with a bunch of sigmoids and.
Do you know what layer is he talking about? Layer 2-3 lateral connections.
He doesn't really have layer 1 through 6 or anything like that. He just goes with the mini column, assuming that the mini column is connected, like all of the neurons that are connected by.
I'm not sure that in some layers I'm not sure they have lateral connections. I know in layer 5 there's output lateral connections, in layer 2-3, and in layer 2-3 there's lateral connections as well as internal connections too. So you're going to get a temporal context and a sharing. I think both of those happens. Is that right, Mark? That I've heard Jeff say that.
Work, and I like it a lot. There's a lot of good things there, and it looks to me like it's doing the best job of modeling 2, 3, 4 as the basic structure of what it's doing. So it's my take on it as far as how it fits in with what we're doing here.
I'd say it's pretty close, but that all sounds like within a cortical column to me. But I think it's also sharing, and you have to think of both. You have to think of how it's computing internally, and also what it's sharing and how it's taking what's being shared with it and to make it a part of its representation.
If I could correct again, what I have walked away from, and I hopefully will never, ever, ever try and do it again, is that the going through the levels makes the data join up as some sort of hierarchical processing. I'm completely on board now with its parallel all the way through, and every single one of the maps as it courses through. And that's the trick, is once you get to that point and you think that that's how the data is arranged, you have to rethink everything about how it's processed and how it's represented. It doesn't ever really come together in the cortex. It always stays separate.
Right.
So that's what I was saying. Lateral connections and the overall large pattern, that's what's presented to the lower brain structures to use for their evaluation and their issuing of commands to the frontal lobes to start actions. So it stays separate all the way through. It doesn't
Absolutely.
Anyway, that's all I got.
So the thalamus now has the opportunity to send more global signals. And that's what we were talking about, Jeff, with time warping and space warping the thalamus can do to sort of control the models that are being stored in the neocortex of reality. It can warp them in different ways.
Well, a lot of the also, oop, I'm getting a lot of feedback for some reason. But a lot of the signals that are going back to the cortical columns are coming from the hippocampus, recycling the signals and strengthening. So do you really think that you can do, I know that's one of Rinkus's concerns with Sparsy, is that you can't model full intelligence without all these other parts to it. So do you really think that HTM models are fully capable of modeling some of the important parts of intelligence without those other structures?
They're going to be necessary. You're not going to be able to walk away from them. Right now we're doing the processing of the stream and what kind of calculations are done with that, but you're not going to get away from the lower structures to actually do a full AI thing. I mean, they're absolutely critical for doing the command and control. Right now, HTM is just starting to really get their feet wet with the thalamus and the connections from that. At some point here, they're going to have to start going deeper into the hypothalamus and what those nodes are doing. They're going to be necessary to go further.
Okay. One of the tricks we were thinking of doing was, since both HTMs and Sparsy, they're good at like really just capturing features, really, and that's really been the goal of AI, is capture states and then assign some sort of action to the states. So since they're good at capturing these states within temporal context and such, it seems like Q learning would be the perfect to take advantage of that. You assign a value to the states that are being represented in the HTMs, and I think that might be one of the first like shortcuts, not necessarily full intelligence, but a nice little cheat shortcut to get something working. But I know it's been talked about why HTMs can only do anomaly detection, but I think if you even if you just slap a neural network right at the end of an HTM or something like that, I think you still could get some sort of state or categorizing recognition from it, at least, just as input.
We definitely do that. I mean, that's what our SDR classifier does to make predictions.
Right.
But you're right. And the Q learning thing I've heard before. I don't know anything about Q learning. It's goal and reward and related reinforcement learning.
Yeah, it's basically just the giant matrix of states and actions, and then you assign for every state and every possible action a percent, like a probability that's at the best choice.
That sounds promising. Sounds promising. Like, one of the things that's limiting right now with HTM is that in order to have a truly intelligent system, you need to incorporate movement. Like the system has to be causal to the movement somehow in order for, honestly, I think really in order for the representation to be truly valid, it has to be created through movement and experience. The reaction of the movement, the sensory experience that was caused by the movement or whatever, that has to be learned over time so that you can learn objects. And HTM is currently, the fringes of the theory right now is how is that movement represented? We're talking about just populations of cells that maybe are representing displacements between different locations, and how that is at play when we're talking about movement and feedback from the motor system back, and that's an unknown area. You know, it's still research.
All right. So you need some sort of at least a little temporary interim device that is kind of sharing information into the input space of the cortical column.
I think you can hack stuff in the meantime until we figure that out. But we won't have really intelligent things until they control their own movements.
Right. Yeah.
For the fellow hackers, this is a thought to kind of show you way, way, way down the road. Okay, assume you've gotten down to the hypothalamus. And by the way, if you're interested in that warping, shoot me a line. I've got a bunch of papers on that in the hypothalamus. There's been a bunch of really cool things on that coming up lately. But assuming that the hypothalamus has got this digested version of a state, and it goes into these lower brain structures, they don't have the layered uniform structure that we're used to seeing in the cortex. They're doing something very different. So what they're doing is they get like a postage stamp copy projected onto them, and they do this weird thing that looks very much so like a Boltzmann oscillating network, and that combines all of these disparate things into a state inside that's represented by for the want of a better description, a circular oscillation. I mean, it sounds really goofy, but it's what it's doing. Look at the olfactory lobe for a really good example of that. So at some point here, at a very high level, that's going to drive some completely different kind of network. And then that network is going to, the output of that oscillations will be projected back onto another set of cortex to develop a drive for actions, to select an action. So even though you're going to be dialed in cortex algorithm, there's more down the road.
Right. Yeah. Well, yeah, definitely, I'm Cairo on the forum, so if you just shoot me those links in a direct message, I'll definitely check them out.
All right, nice interaction, you guys. Thanks for joining from the forum. I think we'll do last call. We're over an hour now, so anybody else have anything to say? Now's the time. Thanks, Brev, for being here. Thanks, everybody. Jimmy, David, Josh, Kai, Sam, Mark, and then somebody left. I forgot who it was. Anyway, I'll see you guys on the forum or on Twitch or whatever. And I'll talk to you later.
Thanks. Thanks, everybody.